Hi everyone, welcome to our Model 3, Planning the Quality Management System, which is part 3 of 8 model comprehensive implementation series of implementing ISO 9001 Quality Management System. We advise that you watch Model 1 and 2 because this model is built on that, but you are welcome to continue from here. With that being said, this model will translate the organizational understanding, which is Model 1, and leadership commitment, which is Model 2, into systematic risk planning. And here, together, we will learn how to identify risks, how to set meaningful quality objectives, and we will learn together how to plan change without disrupting the operations. So, this Model 3 of 8 model journey from zero, we start from zero to the certification of ISO 9001. What we have done, we are not only explaining the clauses, we have a realistic company case study that we are going through to implement in real life. So we have dissected everything and we are starting from zero as if this company is not certified in ISO 9001. This will give you a realistic and vivid picture. Instead of theoretical, you will have a practical understanding of this management system framework. So each model, the way we design our course is built on the previous one. That's why we advise that you should watch one and two. And by doing so, we are creating a complete integrated quality management system for our case study, which is called the organization name is Global Meat House. Now let's look at our case study organization, Global Meat House. The organization type is meat slaughtering, processing, packing, and export organization. Its scale, it has 200 to 500 employees across two sites. The operations we have inside A, livestock reception, slaughtering, primary carcass handling, and initial chilling. And then inside B operations, we have secondary processing, cutting, deboning, portioning, packing, labeling, cold storage, and distribution. This is the same organization we are using across all the models. The market reach for our organization includes local retailers and wholesalers, and then food services operators such as restaurants and hotels, and then it reaches also international market exports. For example, European Union, Middle East, Asia, US, and US markets. The current challenges that our organization has, the annual cost of poor quality is 384,000 USD, which is equivalent to 1.9 of the total revenue. And then we do have the second challenge is customer complaints rate, which is at 2.3 of shipment. And we are going to discuss the measurable objectives later on for reduction and our target. And the third challenge our organization have is temperature excursion with 12 incidents per year. And then we are facing the challenge of traceability gap with 8 incidents annually. And the final challenge we have is export documentation error, which is at 7% of shipment. And we will see later on what are we aiming to achieve for this. The strategic goal of our organization is to implement the ISO 9001 quality management system framework as a foundation for integrating management system, which later on will lead to implementation of ISO 22000 food safety and ISO 14001 environmental management and ISO 45001 occupational health and safety. The critical success factors for our organization, it includes managing quality across 15-kilometer distance between two sites, site A and site B, with seamless integration. This realistic organization will provide the context for all examples, procedures, and solutions throughout our 8 model implementation journey. Now let's recap what we have built so far from Model 1, Model 2, and where we are today. In Model 1, understanding the organization, we have covered organizational context analysis, internal and external issues have been identified, and then we have covered their interested parties identification, including customer, regulatories, suppliers, and employees. And then we have also covered in Model 1 process approach, and we have mapping. We have mapped the process approach there, and that covered from livestock to slaughtering to processing to distribution as a comprehensive map. Then we have covered also, uh, we have defined scope in Model 1, 2 sites operations with 500 employees. The current performance baseline have been established also, which is 384,000 USD cost of poor quality annually. In Model 2 leadership and quality culture, we have covered leadership accountability metrics, and we have created that in Model 2. Quality policy have been established and drafted and with examples and guidelines, which included animal welfare, cold chain, traceability, export, and compliance. And then we have covered quality objectives, and we have set 6 key metrics targets with the real performance gaps. Then in Model 2, uh, we have set the interface control procedure of the 15-kilometer transport between 2 sites, site A and site B. Leadership routines have been established also there in Model 2, and we have established daily routine of the leadership, weekly routine of the leadership, monthly routine, and quarterly routine. Today, in planning the quality management system, we will translate understanding and leadership, organizational understanding and leadership that we covered in both models into systematic planning through risk-based thinking, the quality objectives, and change management. The foundation has been complete, and now we will build the structure. The purpose of this model. Model 3 is going to be crucial because it's translating the understanding of our organization and strong leadership into systematic, structured planning. Model 3 is going to introduce risk-based thinking and not just a concept or a theory, but practically. Uh, we are going to design proactive tools to identify and prevent potential problems before they impact operations and quality. Here we are going to identify the risk, and we will learn how to spot risk and opportunity across all processes. Also, we will design controls and will create preventative measures that will stop inconsistency. And we will link up, the risks to objectives directly. We will connect risks directly to quality goals. The model progression so far from understanding and leadership to risk-based thinking. In Model 1 Foundation, we covered organizational context analysis, process understanding, scope definition, integrated parties identification. In Model 2, the leadership, we have covered leadership accountability, and we have established that we have created quality policy, and we have defined roles and responsibilities, and also we have set the foundations for quality cultures and operational excellence. In Model 3 today, which is planning, we are going to apply the risk-based thinking, risk and opportunity identifications, quality objective planning, and change management. So we have learned in Model 1 the what is needed to be managed. And Model 2, we have established the who is accountable for what. And Model 3 is going to teach us the how to plan systematically to prevent problems before they happen. So what this model is going to cover, Model 3, the core skills that we are going to learn in Model 3. One, we are going to learn how to identify risk and opportunities across processes. We are going to learn the skill of how to focus on high risk interfaces between sites. And we are going to learn how to evaluate risks using simple, realistic criteria. We will also learn how to design controls that prevent inconsistencies. And we will link risks, quality objectives, and then we will learn how to plan changes safely. With real world example of our case study, we are going to use actual risks from meat house operations, including slaughtering processes handovers, temperature control, supplier variability, and labeling errors. We will build practical risks register. We will define preventative control and integrate planning into daily operations. Planning here is not scheduling, but planning is prevention, and we are going to learn that and set examples for this. So, in the context of ISO 9001 quality management system, planning is fundamentally different from scheduling because scheduling is just organizing the tasks over time. But planning here, it means a proactive strategy that will focus on prevention. Scheduling or planning is anticipating potential risks that could disrupt consistent quality and implementation. Quality and implementing controls. So we will learn that our planning here is anticipate the potential risk and accordingly we plan the controls before these issues happen. An example for that, for example, in Global Meat House case study organization, in their operations, this means identifying risk like temperature fluctuation during transport, cross contamination, for example, during slaughter processes handover, or for example, error in allergen labeling. So when we identify these, the planning is we have to plan a specific preventive actions to mitigate each and every risks that we mention. And we will not just sit there and schedule to wait what to do when it happens. So we have to do it in advance. That's what planning is. And we are going to give more examples for that. And for that reason, that's why we have clause 6, because most quality problems were predictable. So let's see what planning actually is and what planning is not. Planning is, again, anticipating failure points, understanding variability, designing control, and protecting customers. So, for example, in the case of a new employees, when we hire a new employee or a seasonal worker, the risks there is if we put them in the process operations, the risk is the variation on its specifications. They will produce something that is inconsistent and will not meet customer requirement. So we're anticipating that and we understand what is going to happen. And what we do to control that, the design we do is targeted training. We will do targeted training and competence assessment to ensure that risk of variability is eliminated. And by doing so, we protect the customer. That's what we mean by planning. Now let's see what planning is not. Planning is not filling up the forms. As you can see with our example, it doesn't apply there. Planning is not guessing. Planning is not reacting to complaints. And planning is not protecting the certifications, it's protecting the customers. Risk-based thinking. Let's try to simplify it because it sounds so technical. In the real sense, it means what could go wrong and why it could go wrong. So, risk is anything that can stop your process from delivering consistent quality, like the example we just said now with the new employee. And it's not a danger, it's not a safety hazard, and it's not a probability mathematics. It's just in a simple form what could go wrong and why could it go wrong. Let's try to clarify the common misunderstandings that are happening, and then let's also try to elaborate the reality. Misunderstanding, people think that risk is equivalent to accident, but in our context of ISO 9001, risk is equivalent to inconsistency. That's the reality. Another misconception, a risk register, people equate it to ISO form. That's a misunderstanding. The reality is risk register is a thinking tool. Other misunderstanding is that risk belongs to QA department, which is wrong. It's a misunderstanding. The reality is risk belongs to process owners. If you review our model 2, and here also you will see later on with accountabilities and roles and responsibilities, risks belong to each process owner, not the QA department. Other misconception is that risk assessment is done once and put in a folder and open it next year for review. That's wrong. The truth is, risk assessment is a continuous and is a living form. Now, there is critical distinction there. ISO 9001 risk is not the same of ISO 22001 risk. So let's clarify this also. First, ISO 9001 risks, quality management system. The definition of risk in this framework is that anything that could prevent consistent quality from delivering consistent quality. That is the risk according to ISO 9001 framework. Example in our case study, supplier documentation gap. That's a risk of traceability breakdown. If the documentation are not complete, we will not have a complete traceability, and that's the risk. Equipment calibration lapses, or if the calibration are not updated for the calibration for the equipment, we will have a variations and we will not meet its specifications. We will have its specifications not conformance. That's a risk according to ISO 9001. The other risk we have is communication failure between two sides. If we don't have documented and well uh, prepared documentation channels and escalation protocols, we will have the risk of interface problems. If, for example, if the refrigerated truck is leaving side A to side B and nobody informs side A and nobody informs side B, who are currently, let's say, are loading other trucks, and then the arrival of the truck from side A is not being communicated to side B. Side B will not be able to receive on time, and in turn, it could cause product spoilage, and that's an issue. So communication there is a risk if it's not systemized. Staff turnover or new staff. Again, competency inconsistency, exactly what we said earlier in our example, is another risk because it will produce variations in quality. So the focus of ISO 9001 risk is process consistency, customer satisfaction, and system effectiveness. Now let's look at ISO 22000 hazard, the food safety management system. The definition here of hazard in ISO 22000, hazard means biological hazard, chemical hazard, or physical agent that could cause harm. The example, pathogenic bacteria like E. coli or Salmonella, those are hazards in ISO 22000 food safety management system. Chemical contamination, like cleaning agent, if they are not food grade and we are using chemicals that will contaminate the product, that's a hazard according to ISO 22000. Physical hazard, if we have metal fragments or glass breaks and enter the products, that's another physical hazard. Or allergen cross contamination, if we don't have, for example, proper line cleaning with SOP, with verification, with testing, we will have cross contamination of allergen, and that's a hazard according to ISO 22000. And ISO 22000 focuses on customer safety and HACCP, and especially in critical control point. So why does this matter? Model 3 address quality management system risks, not the food safety hazard. Food safety hazard are covered later on in our plan ISO 22000 or FSSC in 22000 in the plan implementation later on, which global meat house will integrate after ISO 9001 certification. So definitely both are important, but we have to distinct them that they are not the same. Now, this is very critical to know that risks live at interface. In every interface, in every operation, that's where risk is. From one process to another, from one shift to another, from one side to another, those interfaces are where the risk is. So in our case study, two sides meet operation, risk does not respect the charts and does not respect the register. Risk lives where responsibility change hands. So the insight here we have to take away. If you control any interface, that is your quality control effectiveness. So make sure next time, just look at any interface we are going to give you now, the elaboration of all these interfaces in our case study, and that's where the risks live. Now let's see high risk interfaces in two-side operations. This is the risk-based thinking. This is the risk identification. The risk in from supplier to slaughter, that's an interface there in between. So the risk there is variable animal conditions will affect quality from the start. That's why we have to design the acceptance criteria, the forms, the supplier evaluation, the certificate of analysis, the certificate of origin, and so on. All these documentations have to be complete and procedures are followed. Because when the animal leave from supplier to slaughter site, that's where you control the risk. Other interface is from slaughter to transport. There is a risk in this interface because the delays and temperature deviation will cause carcass quality loss. So if no proper communication, if the transportation doesn't have the insulation or the temperature control, or the other side is not notified, or we don't have the backup plan or the mitigation plan in case of traffic on the road, those are where the risk is and has to be managed effectively. If you manage that, you control the quality. Another interface is between transport and processing. The risk there, poor handover information will lead to rework and rejection. Like the example we said earlier, if any delay happen or any temperature deviation on the road doesn't have a proper, effective management system, if you lose control there, you lose the quality. But if you control it, you control the quality. The other risk interface we have between process and packing. Here, the specification mismatch will result in customer complaints. So if we don't pack according to the requirement, for example, if we are exporting to a different country and we put a foreign language, that will lead to rejection and erode the trust. That's where the risk is. We need to control that risk. And then another interface is between packaging and cold storage. If we don't follow first in, first out, that will create a shelf life issue. We will be selling new product while the old product are sitting there. So if we control that, we control the quality. The other is interface risk is between cold storage and export. If we have documentation error, it will lead to rejection in border uh, uh, through the border. That's why we have to ensure the compliance, and that's why such critical interface have to be owned by the expert, the subject matter expert, like quality and compliance manager. Now, let's try to identify the risks the right way. So, risk identification must be done by people who run the process, not just in the meeting room. This is very critical. And mainly in every organization, we have to understand that in order to identify the risk effectively, it has to be done with the process owners on the table, with the process owners walking the floor, and with the process owners giving their feedback throughout the design, not just in the meeting rooms. Now, let's explore how to identify risk by process. And this is very critical to learn here. Process, the livestock sourcing. A typical risk in this process is inconsistent animal size held from diverse suppliers. That's why we said earlier that supplier evaluation, documentation, and procedures of and with criteria of acceptance have to be in place because this will determine the consistency of the quality downstream. The real example, the carcass from different farms will vary greatly in weight or fat distribution, which will affect the yield inside a slaughtering house. The impact of quality there is variability in meat cuts and fat content, which will affect quality, consistency, and customer satisfaction. The other process, which is slaughtering, the typical risk in this process is inconsistent stunning or bleeding procedures across shifts or sites. The real example in our case study is insufficient bleeding at site B will lead to blood spot and reduce shelf life, especially for export orders. The impact on quality here is reduced shelf life, unappealed appearance, for example, the blood spots, and potential microbiological growth due to residual blood. Then we do have transport process. With transport process, the risk there is uncontrolled temperature fluctuation or extended transit time during the intersite transport. For example, we say like unexpected traffic or breakdown. Uh, the real case study example is trucks carrying chilled meats that might get held up in unexpected traffic between side A and side B, which will cause internal temperature rise. And that will affect the quality by accelerated bacteria growth, the unpleasant smell, and compromised freshness, which will lead to product spoilage. Now, in the processing, the risk there is inconsistent cutting or trimming by new or less experienced workers at either processing plant. And in our case study, the newly hired butchers at site B is struggling to meet precise cut specifications for premium retail products. The effect on quality there is non-uniform portion size, excessive trim loss, and deviation from customer specifications for specific cuts. The packing process, uh, with packing process, the risk there is incorrect product label or foreign language label for different export markets. In our case study, a batch of lamb destined for Japan, for example, incorrectly labeled with Arabic language details outside A's packing line. The effect on quality here is product rejection, regulatory non-compliance, costly relabeling, and loss of market trust, of course. And then we do have storage. The storage process, the risk there is malfunctioning chillers or improper tracking leading to cold spot variation. A real example for our case study is a walk-in chiller door outside A left ajar overnight, raising internal temperature and affecting storage product. The effect on quality there is increased risk of bacterial contamination, spoilage, and reduced product safety and overall quality. So I hope this risk identification process has given you a clarity of how to uh, to map your process-based thinking, risk-based thinking. And let's move now to which risk matter the most. It's imperative to remember that we have to keep it simple and usable. We don't need to complicate it because we are not here trying to score for ISO. We are prioritizing for reality, for our customer protection, for the reputation, and for the regulatory compliance, and for our ethical business reasoning. So we have to make it as simple and usable as possible. The likelihood, for example, just ask yourself questions. How often could this happen? And the answer doesn't need to be superficial. It has to be based on actual experience, the history in the company, the benchmark in the industry, or the publication's indication. And then we do have impact. You ask yourself, what happened if this risk really happened? And when you ask yourself like that, consider the complaints that will come from that, the recall, the waste, and overall consequences. And based on that, you can uh, assign the priority. And then we do have detectability. Ask yourself, if this risk happen, how quickly would we know? Do we have a CCTV? Do we have alarm? Do we have notifications? Or do we have a blind spot that will take days and months to identify? As based on that, you will design your control. Now, let's look at the simple risk evaluation model here. Uh, the factor and question to us. Again, likelihood, how often could this happen? Impact, what would happen if this risk really happened? Detectability, how quickly will I know that and try to reverse it? So example here we have from slaughtering to processed transport. The risk here, the risk and priority. Temperature deviation, we classify it as high. Because when the temperature deviates during the transportation, it will spoil the product and there is no reverse corrective action there. So that's a very high risk. If you talk about the documentation risk, documentation error, we classify it as medium because it could be corrected and it could be detected and it could be reversed. And the impact also is not severe. The impact of temperature deviation, if you sell product that have temperature deviated during the transport, the consequences are very, very catastrophic. Even the recall and leave alone the if it's consumed by customer, but the recall, the cost of rework, and the disposal, all of that consequences, we prioritize it as high. The risk of delay, for instance, delay we classify it as medium because it could be reversed, it could be corrected, and people can learn from it. Now, the risk control, essentially, in essence, it means the process design. What do we mean by that? The controls must be practical, something that can be done by the process owner, something that is affordable, and something that is used daily. It's not complicated. So let's see from risk, let's identify each risk, identify the control, and produce the evidence. We have temperature deviation is a risk. The control for that, for instance, the insulated vehicles plus the monitoring with real-time notifications and assign an owner and rapid corrective actions and training. All these things will be the control, and the evidence for that will be temperature log and training. Then we do have supplier variability is a risk. The control to control the supplier variability, like we said earlier, we have to have approved supplier program that will include the supplier evaluation, the documentation, the assessment, the audits, and so on for the supplier in order to be approved and monitored. And evidence for that, each supplier will have complete record with the set criteria. Then we have label error is a risk. To control that, we have label verification steps, SOPs, and validations all throughout the production, and that the evidence for that would be the checklists and other applicable documents. The other risk we have is the skill gaps for the new hire and seasonal employees. The control for that is targeted training, competence-based evaluation, and trials. All of that to be carried out before the actual performance of the product that is going to customer. And the evidence for that will be competence records that are with training management. Handover errors. The handover error are risk, and the way to control that, there will be acceptance criteria, authorizations for rejections, communication protocols, and rapid corrective actions. All that should be set out and SOPs, and the evidence for that, receipt inspection and ownership. Now let's look at opportunities because opportunities and risks come handy. In every risk, there is always an opportunity. And this is what the ISO tell us that we should improve, not just protect. So let's turn risk into opportunities in practice here. Risk area, opportunity, and benefit. For example, high rework is a risk area. What opportunity do we have there? We have to simplify the process of the rework, and by doing so, we will benefit the cost reduction. We have suppliers issues is a risk area. In order to get opportunity out of that, we have to deploy the supplier development, such as coaching, sharing the resources, sharing the visit, working in partnership to develop the suppliers and to eliminate the issues. That's the improvement there. And by utilizing that opportunity, we'll benefit by establishing a stability with the supplier. The next, we have complaints. Those are issues area. What can we learn from complaints as opportunities? We have feedback analysis. Every complaint is a lesson. We have to analyze, put down the trends, learn the lessons, and share the outcomes with the operations, with the management, with all interested parties, and learn from there. And by doing so, we earn market trust because each complaint, when it's analyzed, the feedback is analyzed, and the loop is closed effectively, it will never happen again, and there will become fewer and fewer, and customers will trust us more and more. The gap analysis or data gap, sorry. The data gaps is a risk area, and the way to the opportunities in this risk area include establishing better monitoring of these gaps. And by doing so, we are able to make faster decisions. Quality objectives are risk control in a real sense because the objective is set to monitor the risk and to meet the KPIs and also to assign accountability and responsibility across interested parties. So every objective should answer one fundamental question, which is what risk does this objective control? Has to be measurable and specific, and each objective should be linked to a control. So quality objectives must be directly linked to the risks we have identified. They are not abstract goals, and we will see that handy right now. They are targeted control that address specific vulnerabilities in our processes. So the objective planning model for two sites operations. So let's look at those objectives. How did we set them? Inside A, the slaughtering process, inside B, the secondary processes. Objective. Objective one, reduce temperature deviation. What risk does this objective address? It addresses cold chain storage. How do we measure these objectives? We measure it by the percentage of the compliance. And who owns these objectives is the logistics, the process owner. Again, another objective is reduce labeling error. What risk does this objective addresses? It addresses the risk of export rejection, like the example we had that products labeled with Arabic that was supposed to go to Middle Eastern market went to Japan. So how do we measure this? The error rate is the way to measure this, and who owns this is the process owner, the packing team. The other objective is improve supplier consistency. And the risk this objective addresses is raw material variation. And how do we measure this? By rejection rates, especially inside A, and the owner, the process owner, is a procurement. And then we have close actions faster. Any action have to be closed faster, not only the quality complaints, but all the actions no pending should be allowed, ideally. And so what risk does this addresses? It eliminates repeated issues, and we measure that by the percentage of closure, and each action will be owned by the process owner. Now, how does model 3 right now connect to model 2? In model 2, we establish the who. So, for example, the CEO was accountable for overall accountability. The operations director was accountable for cross-site coordination and interface ownership. We discussed this in model 1 and 2. And then quality compliance also is responsible for quality management system ownership. And then we have each site manager is responsible for site specific operations. And then each supervisor is responsible for daily executions. And then this in model 3 here, it established the what. What are they managing? We know the who, but what are they managing here? So in model 3, each leader now has a specific risk and objective to manage. The CEO will manage cost of poor quality, which is at 384,000 now and must be reduced to 30 to 50% in the next 18 months. CEO also manages strategic business risk, and also CEO manage resources allocation for risk control. And then what does the operations director manage? They manage interface 15 kilometers transport between two sites. Operational directors manages temperature excursion risk, which recently we have 12 incidences per last year, and we aim to reduce it to zero this year, which we discussed also in model 2. And then the operational director will manage cross-site coordination failure. The quality and manager compliance will manager will manage traceability risk, which last year we have 8 gaps per year, and this year we want to eliminate it and to be 100% traceability success rate. And also the quality and compliance manager manages uh, customer complaints risk, which last year was at 2.3 per year, but now we want to reduce it to less than 1.5%. And also, the quality and compliance manager will manage regulatory compliance risk. And then we do have site each site manager will manage a specific process risk, and also they will manage specification conformance. Last year we have in our gap analysis in model 1 at 94%, and we want to take it up to above 98%. And they will manage equipment and competence risks. So model 2 establish who owns the quality, right? But model 3 establish what risk they control. And together they will create accountability for prevention. Now, change is a risk event. The change management is a risk event. So most incidents actually happen after change. Planning change properly, the change management must be planned properly because that will be essential to maintain the quality consistency and also avoid disruption of any quality, not only quality consistency, but also the operations. So if any unplanned change happen, we have to know that that's an uncontrolled risk. Now let's see how to plan the change properly. Number one, if we are changing the supplier, the risk there is new supplier will introduce quality variation. So in order to control the supplier have to go to undergo the trials, the audits, the analysis, the verifications, the validations, and then the approval. That's how and has to be controlled systematically. You remember when we talk about supplier documentations. And then if we are introducing new equipment, the risk with the new equipment is the process instability. So in order to control that, we have to go through validation before we implement any new equipment or install any equipment. And then before entering any new market, there is a risk of compliance gaps there. That's why we need to analyze the new market and control the require and know the requirement and meet and or exceed all the requirements. That's how you control that. And then when we are hiring new staff, the the risks there is, the skill gap, even experienced staff have to be reintroduced and retrain competency, and then uh, let them, integrate. That's how you plan the change properly. Now, model 3 outputs. What should we have after completing model 3? First, the risk register. We should have a comprehensive process-based and realistic risk register documents over all critical interfaces within global market house operations. And this register must identify potential hazards, assess their likelihood and severity, and outline existing control. Example for that, a risk identified might be microbiological contamination of carcass during chilling, which directly impacts the product safety, which is a quality objective. Now, we also have uh, the second output. It's interface control. It's specific documented control for critical handovers, particularly between slaughter and processing stage. These controls should ensure seamless transitions and mitigate risk identified at these junctures. Example for that, implementation of a mandatory temperature locks protocol and visual inspection checklist for all carcasses transferred from chilling to butchering line, ensuring compliance with product quality and compliance objectives. The third output should be the defined control, a clear set of preventive measures designed to avoid issues before they occur rather than simply reacting to failure. So these include standard operation procedures, SOPs, calibration schedule, and hygiene protocols. Example for that, daily operational sanitation checks and documentation equipment calibration records for all processing machinery, preventing foreign objectives contamination or incorrect portioning. This will support operational efficiency and product quality. The fourth output is quality objectives or our quality objectives. Our quality objectives should be clearly defined and directly linked to the identified risk and correspondent controls. From Module 1, recall the six quality objectives in Module 2 and in Module 1 actually. For example, first, product safety, ensuring all products are free from harmful contamination. The second, product quality. We have to meet the specifications for taste, texture, and appearance. To meet the third objective, which is operational efficiency, we have to optimize processes to reduce waste and time. Fourth, compliance. We have to adhere to all regulatory and internal standards. Customer satisfaction. We have to meet or exceed customer expectations. You remember we talk about all this. Waste reduction, maintaining material and resources wasted. So the connection here is each risk in our register should map to one or more of these objectives, right? Showing how mitigation that risk helps achieve the objectives. So for example, a risk of packaging material defect would be linked to product quality and also waste reduction. Fifth output, which is change planning method, a documented and actively used methodology for planning and implementing change within operations. So this include a formal processes for impact assessment, approval, and verification of new processes, equipment, and materials. Example for that, the Global Meat House Change Management procedure documents, which mandates a multi-departmental review and approval for any new ingredients supplier or significant process modifications. For example, introducing a new cutting technique. This will ensure consistency with compliance and product quality objectives. Building the risk register. Essential components of building any risk register include process identification. First, we identify the process, and then we describe the risk, and then we assess the likelihood of that risk, and then also we evaluate the impact of the risk, and then we see what do we have currently to control that risk. After that, uh, we we conclude from all these 5 points the risk priority, and then we carry out the action plan, and importantly, we assign the responsible person or responsible risk owner. Let's look at the risk assessment in action now, what we just discussed here, just in 4 or 5 steps. So, for example, from two sides, meet operations, showing how risk-based thinking prevents problems. First, identifications. We identify temperature deviation during transport between two sites. Then we evaluate. You go through the evaluation after the identification. You evaluate the high likelihood, high impacts, and medium detectability are the outcome of the evaluation. Then control. Insulated vehicles must be in place. Real-time monitors must be in place. Acceptance criteria also must be in place. So you identify, you evaluate, and you control. Next, what do? You monitor daily temperature log, trend analysis, and corrective actions. That's how you can replicate this throughout all the risks. Just identify, evaluate, control, and then monitor. So let's link risks to our daily operations. The risk management, of course, have to be integrated into our daily work, and we have not to think of it as if it's something that is separate from the operations. So the best risk register is the one the process owners actually use. From reactive to proactive, let's see what are the two difference between two. Reactive approach, the organization or the risk owner will wait for the problem to occur and then respond to customer complaints, like it's urgent, let's do it. Then fix issues after they happen, have to be fixed, and sometimes give the customer incentive, just to please them. And sometimes they will blame individuals, especially quality assurance will get blamed for that, or some production or warehouse guy. And then They will repeat the same mistake over and over again. They don't do anything. They just wait for the problem to happen, then put the urgency attitude, blame somebody, give some gifts to a customer, and nothing effective. But now let's look at the preventive approach. The organization will anticipate the potential problems, do the analysis, risk-based thinking, process approach, just figure out what could go wrong. Again, what could go wrong, right? And then you plan for it, design control into processes. Then you prevent the issues before they occur. Then you improve the system, and then you learn and you adapt continually when something happens. There is no blame at all. Now, key success factors. First, for the risk identification and risk control and risk-based thinking and operational excellence, it's start with process. Have the process owner have to be involved. So risk identification and control design must involve the people who actually run the process daily. We don't have to leave them behind. If it's about cleaning, if we are designing the allergen changeover cleaning, who should involve the people who are actually doing it? If we are talking about the line change or the product line change or the packaging specifications or the labeling procedures and control to prevent the error, people who are doing it have to involve it there. And then we do have to keep it simple, and it has to be appealing and it has to be realistic also. We don't need to sound too technical and out of touch. It has to have realistic criteria that people who are using them on the shop floor there or in operation will understand, and they will implement it seamlessly without thinking a lot, or because when you complicate it, that's when people skip it. And then we need to focus on interface, like what we said before. Those are the high critical areas, any type of interface. So we need to pay attention to handover points between departments and sites or processes where risk is high, and we need to apply strict control measures there. Then we have to apply the continuous improvement or continuous assessment. So risk assessment, like we said before, is not something you do once and put it in a folder and review it next year. It's a living document. Okay, so it has to be ongoing process of learning and improvement and updates continuously. Common pitfalls we need to avoid. First, we do have what don't work actually. Before we look at what work, uh, we do have organizations sometimes they just copy risk register from other companies or from consultant. That doesn't work. Treating risk assessment as a paperwork exercise, that also doesn't work. Delegating all risk works to QA department and everybody avoiding it doesn't work. If you watch model 2, you will find how the risk was the ownership. Even earlier in this model, ownership is dispersed and risk is owned by everyone. So here it doesn't work. Using overly complex scoring system doesn't work too. Conducting risk assessment only once per year doesn't work, and ignoring inputs from frontline workers doesn't work. Inputs from frontliners have to be considered. So what worked? Building your own risk register from real experience, real processes, and real operations. Making risk thinking part of daily decision making. The mapping, the process approach, and the simplifications, all this have to come up during daily toolbox talks, daily meetings, daily floor walks, or weekly. And then engaging process owners in risk management is a must. And also using simple practical evaluation method is the best way. We don't need to sound sophisticated to complicate the issues when they are simple. Reviewing risk wherever change occur is the way forward. Risk is not a one-time problem. And then listening to people who do the work, building a safety net and the feedback loops that is safe for everyone without the blame and the near misreporting. These all come with excellent quality culture, which we will explain later on. So these are what worked and what don't work on the left. So you know what to avoid. Then let's see our action plan for now. So our action plan to build uh, the risk-based thinking and apply the controls and produce the evidence. So we start with one process. Choose choose a critical as an exercise. Let's do this. Choose a critical process and identify its risk with the process owner jointly. Right? Don't do it alone. And then evaluate with the simple tools. Use the three factors model like how many times can it happen, the frequency, the impact that it will have, or the consequence, and then the detectability period. And then accordingly, just design the control, create practical, affordable control that can be used daily. After that, you can document and communicate. Once you align with all the teams that are involved, then you can document and communicate with all the interested parties and record your risk in your risk register and then share with all the teams. And once you have done that, just move to the next one and expand systematically. Okay, so we are preparing now for model 4 support processes. So in model 3 so far, I've set the foundation for risk-based thinking and accountability. But in model 4, we will build on this by providing the tools and systems to execute uh, our risk-based thinking and accountability plans. So what have we accomplished in model 3? Risk-based thinking framework, we have established that. Risk have been identified across all processes. Quality objectives have been linked to real performance gaps. Change management procedures have been defined. Leadership accountability for risk management. And what models 4 will provide is model 3 have identified the what need to be controlled, and model 4 will provide the who, which we talked about it earlier. So let's look at model 4, the resources and infrastructure that we'll cover in model 4, that will include equipment, facilities, and cold chain system. Then we'll cover also maintenance program, prevent temperature excursion, and then we'll cover calibration system for measurement accuracy, all under resources and infrastructure. And then in model 4, we will cover competence and training, under which will include training program to address skill variations, competence requirement for critical roles, and effective evaluation. And then in under communication and communication system in model 4, we will cover cross-site communication to prevent interface failure and internal awareness of quality objectives. And also we'll cover external communication with customers and regulators under communication system. And then in documented information in model 4, we will cover procedures that reflect risk control, records that provide evidence, and then we'll cover document control without bureaucracy. So the connection here, model 3 is planning what to do. Model 4 is support, how to control it. Uh, so risk management here without resources will fail. So model 4 will give us the resources that we need to execute our plan. Risk-based thinking is not a fear-based thinking. It's a respect for reality. So If we control risk, we control consistency. If we control consistency, certifications become routine. Uh, our achievement in Model 3 so far, we do have risk register for global mid-house operations have been created. Quality objectives have been linked to real performance gap. Defined, uh, defined change management procedures have been established, and we established a solid foundation for Model 5, Model 4. So why is Model 3 a critical milestone in our eight models journey? Model 3 has been instrumental in shifting our approach from simply reacting to problems to proactively managing potential risks. So, this foundation understanding is a vital step toward building a truly robust and resilient quality management system across all eight modules. So, from reactive to proactive approach, we now have a new era of quality. So with the tools and mindset we have developed, just a second. So with the tools and mindset that we have developed in this model, our quality management system is evolving to be fundamentally preventative, not reactive anymore. So now we have the capability to anticipate challenge, design effective controls, and construct a quality system that not only protect our customers but also strengthen our business against future uncertainties. And this is a significant leap toward our operational excellence and also customer trust. Yeah, just a second. Uh, okay, where we are. Okay, what's next? We are going to transition to model 4. Yeah, sorry for that. So, what's next? That is empowering our quality with model 1 with model 4, sorry, as we transition to model 4. It will equip us with essential resources, competencies, framework, and infrastructure necessary to support and sustain the robust quality management system, and with the objective that we have established here. And it will prepare us to turn our strategic insight into actionable and well supported processes. Uh, now, the summary of our Model 3. Let's see the implementation checklist here. We have covered risk-based thinking foundation, which highlights the understandings, the difference between ISO 9001 and risk and 9000 and ISO 22000 hazard. It has also covered recognizing that doesn't necessarily risk is equivalent to sorry guys, I've been a little bit distracted here, so let me just get back to it. It recognized that risk is equivalent to inconsistency and it's not an accident. And it we covered also in risk-based thinking foundation that know that risk management is everyone's responsibility. The second thing we covered is risk identification complete. So process by process risk analysis, we have conducted that. Interface risk, we have identified that, especially with 15-kilometer summary. So we have documented supplier equipment and competence risks, and risk register have been created with process owners' involvement. And then we have covered risk evaluation practices, which include simple likelihood and impact assessment that we have used, risk prioritized based on reality, not complex scoring. We stress that, and also high priority high priority risk with identification for immediate action. We have covered risk controls design, and that include controls are practical, affordable, and daily used, evidence requirements defined for each control, and process design incorporates prevention. And then opportunity identified, cost reduction opportunities from risk elimination, process improvement opportunities documented, and efficiency gains linked to risk control. And then we do have quality objectives linked to risks. Each objective addresses a specific risk. Objectives are smart and measurable. Leadership accountability assigned for each objectives. Then we do have change management procedures. We covered change is recognized as risk event, and change planning procedures. We have established that, and also trail and verification process have been defined. So we are ready for Model 4, right? So if you can check all above, you are ready for Model 4. So because planning without execution in Model 4 is just a paperwork. The complete journey, like we highlighted before, we have Model 1, understanding the organization, Model 2, leadership and quality, and Model 3, planning the quality management system. Uh, the foundation in understanding the organization in Model 4 includes context analysis. We have completed that process, have been mapped there, scope have been defined in Model 1, and performance baseline of 384,000 USD. Cost of poor quality have been defined there. And then in Model 2, accountability establishment that we have done there, it covered leadership structure, definition, quality policy have been created there, and 6 quality objectives have been set in Model 2, and also interface ownership have been assigned. And in Model 3 today, we have covered, which is a risk management establishment. We have covered risk-based thinking framework, risk register creation, control design, and change management procedures. The models ahead, you have Model 4, which is support processes. Model 5 will be operational control, and Model 6 will be performance evaluation. Model 7 will be improvement, and Model 8 will be certifications readiness. Model 8. So the progress so far is 37.5% complete, 3 out of 8 models. And you have built the foundation. Now you will build the system from the next model. Thank you. That's all we have for now. Not going to repeat those. We have covered those already. So please subscribe to our YouTube channels for the updates. We are going to update Model 4. If you find it helpful, also share it with your friends. And you can visit our website also for free resources and training material at qhsc360.org. I'm your host, Walball, and thank you for watching, and hopefully we catch up next time. Appreciate it. Thank you.